Okay. Testing, testing. 1, 2, 3. Got that started. Got the music started. Now to put on my face. Ah, there it is. Okay. Got the board loaded. I think I'm almost on time. Yeah, I was almost on time today. How nice is that? Alright, well then you know what? Then that gives me a little bit more time to work on the promo, which I think I'll do nowish. So, pardon me while I get that ready. Let's see. Ta-da. So what is today's lesson on? Alright, so today is once again a little bit different. I did have a student I thought I was scheduled to have, but what did I get? They are on break. They were on spring break, I forgot, for like a week, and they're barely starting back up next week. So yeah, can't really teach if there's like, or tutor if there's nothing to cover. So I'll have that again. So that means today is free, which is good, I think. Yeah, good to get some stuff. All right, and I think I try to alternate. Between like fun math and like actual math. So I think today we'll do absolute values. Yeah. So for last week, I covered more on whatchamacallit, deck building math, which I think is fun, right? It can be applied to, you know, card games. But today is going to be a bit more practical. Kind of. As practical as someone who's taking classes on absolute values can be. If you're just a person who doesn't have that kind of class or isn't doing that kind of mathematics, then it's almost as impractical as someone trying to do math on a card game if you don't play it. But hey, you know what? That's fine. It's all numbers. It all kind of works out. Oh, look at that. Everything lined up. The music, the timer, my face. Ah, how nice. Oh, wait, I think the music stopped. Nope, no, it's still going. Okay. Alright, so I'm gonna try to, again, copy-paste a little bit. Oh, shoot. I was supposed to advertise in one other spot. If you'll just give me a moment, I will try to do that as quickly as I can. Here we go. Wait a minute. Do I have my tags? Am I? Yeah, I'm tagged as a Vtuber. Okay. Sorry. So I tried to advertise when I am on live streaming, like now, and I'm supposed to do that beforehand and do all my checks. Kinda mess it up a little bit, but it's okay. I'm getting there. I am live now until da-da-da. Okay. Alright. I don't know if this will go through. And again, apologies for the delay, the kind of the boredom, the nothing special happening right now. But that's kind of how it is sometimes when a lot of this content is well, I shouldn't say content, it's tutoring. But I guess, well, there's no one here to tutor, and I guess it is content, huh? It's kind of improv. in the sense that I should have a proper lesson plan beforehand, and I usually try to. But if someone comes up with, like, let's say a math kind of problem that I forgot that I've handled a long time ago and that I need to try to remember, then it's just kind of learning as I go. So to kind of keep that up, to kind of stay sharp, and it's not rely over too much on like a structured format, I try to pick things as it happens and go over it as it goes. But today is going to be on absolute values, which is actual math. It's not like fun video game or card math. Just to, you know, sharpen my skills, go over things that I haven't gone over in a while. And if I can just get the screenshot going. Yeah. Alright. Copy. Paste. Hey, there it is. Alright. Let's try to move that off to the side. So again, if anyone's here and they need help with math, hey, I'm here, right? But until then, I'm just going to try to go over something that is the fun math. It's not derivatives. Derivatives. That's so hard. No. Today is about absolute values. And what I like to try to do is not just simply go over a lesson in the sense, because I feel like there's plenty of very excellent and competent teachers, material, YouTubers that kind of go over this is the math and this is how you do it, right? But I like to kind of, how do I say it? They kind of go over cool things, like either like a complete overview, the kind of thing that you want to just kind of cram in like the beginning of a test. And let's say, for example, that's like the night before and you're just like, oh my gosh, I have to review all this math, but I don't really want to. And then maybe you could just pop in a quick video and watch it, and they'll kind of go over everything. You're like, oh, okay, that kind of makes sense, as like a refresher. That's one thing, right? And I think they have that niche. They do that very, very well. Another thing I try to do that's a bit different is, for one, provide, you know, tailored content. So it's not just like a general overview. It's more like, all right, you have this, we can go over it together. But also, to kind of really lean into that, I like to pick one subject and kind of go over it in a way that makes it familiar, makes it kind of casual, makes it less homeworky and more like, all right, this makes sense. So for example, absolute values, right? It is something that it's used in functions to kind of point out a graph, where I think in a later example it shows it's all functions, right? A lot of algebra and math, it's all functions, it's all graphs, it's all basically art with numbers, where you have something here and then it kind of looks like that usually, where you have maybe a function and the absolute value is like a mirror version of it, right? But then to kind of more lean into this concept of what is an absolute value, it is a specific math notation that has this thing on it right there. It's that little kind of gate drawing onto the sides. And the reason why it has that gate is to say that this number is basically is a solid, real, whole, complete number. So they use it in a very specific way for functions. But before that, it can also be used in a way to measure something like distance, right? So say, for example, if you are at point A and there's point B, and you're trying to go from one to another, right? Bam. Now, the funny thing about math is sometimes if there's like points on a graph, they can be things like negatives, right? So whether you're going from like this point, which might be, let's say, -5, to this point, which is -2, right? You're going from -5 to -2 on the x-axis of a graph. And then you think, well, okay, so there are two negatives. Isn't the distance like -3? Because that's like, you know, kind of -2, -3, -4, -5. Yes and no, because you are crossing 3 points, but because distance is always kind of measured as a positive thing, it cannot really be negative. And so that's kind of what absolute value does, is where you can kind of go from negatives to positives to negatives, or just go any which way willy-nilly. But it recognizes that the distance to go from one place to another is always going. It's always going forward. It's always positive. And so absolute value is just like a notation which says, yeah, no, it's actually 3. So if this distance was x, then your answer would be 3, because it basically makes anything a positive. That's basically what it is. So even if you go from A to B, and then B to A, and then A to halfway, and then back, and then you kind of zigzag all over, right? What absolute value does is it kind of calculates, and it says, okay, all these numbers aren't just like, yes, you're going backwards, you're going forwards, you're going all these directions, but because you're still the displacement from one area to another, that is always going to be positive. You can't have like negative distance unless you, I don't know. How would that even work, negative distance, right? You have to like get sucked into like a black hole and like collapse onto yourself and have like super dense gravity, right? That maybe that's how you get negative distance. Negative x, maybe? I don't know. But typically to go from one place to another, here it's still +3. To go from A to B, to go back from B to A is still +3, because we're thinking about how much you walk today, and you count steps, right? If you're counting steps for like an app or some kind of game or something, you're counting your steps even if you're going from one place to another back and forth, even if you're walking in a circle, those are still steps. So this is a distance, this is a distance, this is a distance, +3, +3, +3, all the way around, right? And again, absolute value isn't like adding all these together. I mean, if it's a function, kind of, yeah, but the main thing is just to say that when you have this thing, the little gates, it just means you're going from one distance to another. Okay, that's kind of the idea, right? That's how you can put it into practice. Now as for homework, as for math, as for algebra, they do it a bit differently. Alright, they have it as a, I believe, as a function. So, where, let's say, for example, you have, alright, here's this thing. They say that, okay, in a way for absolute value to work, the numbers inside can change, right? The values of x can change, but it still has to be kind of positive. Like, it has to work. So, for this example, right, where they have 8 equals -2x minus 6, they say that no matter what x could be, right? It could be one number, it could be another number, it could be a positive or negative number, whatever it may be, it still has to result in a value that equals 8, right? And that's kind of the thing, where I believe if you have something like -8 equals absolute value 2x minus 6, I don't think that works. Maybe it does. Math is weird sometimes. It might work, but I don't think it does, because usually absolute values can have to figure out a positive value. It almost always has to be positive, because again, this is like distance, displacement. So unless they bring up an example where there is a -8 as an equal answer, then we could do that. But for now, let's just kind of assume that it's always displacement. Alright. Now, the funky thing that I have with this textbook, this school book, this PDF, this thing, is that it kind of gives you the answers. So there's not really a lot of room for, let's say, discussion or kind of thinking or kind of a lot of, there's examples, sure, but it's like almost like a teacher's school book, right? If you If you ever have like a school workbook, you know, it just has like all these questions, and then for the teacher's edition, it kind of just has all like the answers next to it. So it's something like that, right? Or the answers are in the back, I think. So we're just gonna try to have to pretend as if we don't see this part, and take it step by step. Alright. So, to take it step by... Oh, okay, here it is. Yeah. Alright. So, oh, okay, I think it does work with negatives, maybe. Pardon me. I don't think it does. I could be wrong. Yeah. We'll find out. We'll find out together. So, for here, the absolute value means that if we have a value on the inside value could be either 8 or a negative 8, because what the absolute value does is it always sets it to a positive value. So, just like with the distance, right? If you went backwards 1 feet, you still went 1 feet, so that turns into just a 1. Right? If you went forward 1 foot, then you still went forward 1 foot. It turns it into a 1. So with what's in the absolute value can be positive or negative, but it always reverts it into a negative value. And so because it always makes into, a positive value. I misspoke. Okay, whatever's on the inside, whether it's positive or negative, always makes into a positive value. So even if you have something like negative 100, the absolute value of that is still 100. Because maybe you like lose $100, but that's still $100 that you lost, right? You didn't lose negative $100, and then all of a sudden you like are given negative money? No, wait, you owe negative money? I don't know. That's kind of a weird thing. If you lose $100, it's $100 that you lost. There is no like negative 100. You still can lose it, yes, but it's still the same value, right? Maybe the closest you can get to like a negative dollar value is like a coupon, because coupons expire. So then once they disappear, then that's like negative value that you have because it's no longer there. I don't know, but again, even if you're given $100, then that's still only $100 that you get. It is the objective thing. It's the distance, it's the amount. Alright, just trying to hammer that home. But because the inside could be positive or negative, you're going to get this weird funky stuff like this. Where then you have to set the, basically, it can equal a negative because its negative will ultimately be a positive. Again, it's a little funky now, but bear with me. Okay, can I erase this? Yes, I can. So what they do is they first. I'm assuming that anyone who's listening kind of knows about math. What you do to one side, you can do to another, as long as they're equal to each other, right? So if you have like a 1 equals 1, if you add 2 here, you can add 2 here. So to that end, what they do is they add 6 to both sides, so that the 6's cancel out, and then you're left with 14 and 2x. That's kind of how they got that there. And then from here, just like how you could do from one side to another, you can divide by 2 or multiply by 1/2 to both sides. The 2's cancel out, and 14 divided by 2 is 7. Alright. I'm just kind of walking over it again. And if anyone's actually wants me to slow me down, is watching this live, let me know. I think it's a bit easier on the VOD, because then you can kind of just like pause or rewind and say like, alright, I kind of get it. But yeah, hopefully that helps. So for here, again, you do the exact same process, right? Plus 6 on both sides. But instead of getting 14, you get negative 2. And then you multiply by 1/2 on both sides. And instead of 7, you get negative 1. Now what this means is that for this equation, right, 8, 2x minus 6, it can either be 7 or negative 1. And the reason why that works, can I guess I'll just draw it off to the side. Alright, so 8 equals 2x minus 6, where x is equal to 7, and x is equal to negative 1. Now, math can be a little weird, but thankfully it's kind of solid. It kind of makes sense. So, the reason why this works is because like this. If we go into the reverse, right? They showed you how to basically solve it to get a value for x. But why does this work is because let's plug back in the x to this equation. So, and this will kind of demonstrate the power of absolute values, right? So say for example if you have 7, right? And what would be an example? Let's say you're walking around and doing, I don't know, some kind of exercise, right? Let's say you're running around doing exercise on a football field. All right, let's get these. No, soccer field. Ah, yeah, soccer field's better. Yeah, because you could like run, because they're for soccer and kicking balls and stuff. All right. So, well, actually, football kind of works because they actually have yardage. If you have like first down, second down. Sports ball. Let's call it sports ball. All right. First down, right? You go this many value. You have a guy that can do this and a guy that does this, right? Where you're gonna try a play where a guy moves 7 yards, and he can do it twice in this play, but then he gets tackled and gets pushed back 6 yards. Sure, why not? Alright. So you run this first play, he gets the yardage, you think 14, because 7 times 2 is 14, that's great, but then he gets pushed back and pulled back, and he's still holding on to the ball, and he doesn't take a knee. And he loses 6 yards. Then that total is an 8-yard gain. That's great, right? So you did all this to 14 minus 6, and then you end up here. And that distance from where you initially started, total, was 8 yards. Alright. But then you're going to try this other insane play, right? Where it doesn't work out, where you put in your second string guy, you think, maybe he could do it. But instead, he does the complete opposite, right? Where he goes negative 1 yard twice, so instead of going twice as forward, he goes back 2 times. Oh wait, I should do that. And then so that would be, was it 2 times negative 1 x. I should make my numbers more clear. So this, sorry while I clean up a little bit. Yeah, I think that's a bit nicer. Alright, so he loses 2 yards. And then he gets tackled again by the same quarterback. No, not quarterback. Linebacker. By the same linebacker, and he pushes him back another 6 yards. Then all of a sudden you lose 8 yards total, right? So you're like, oh great, we did this great play and we tried to run it again, but this guy was an amateur, and instead of gaining 8 yards, gaining 14, minusing 6, and gaining 8 total, we now lose 2 yards, get pushed back 6, and now we lost 8 total. How terrible. But that's one way to look at it, right? There's a positive yard that you gain and negative yards that you lost. But the fact is that is still 8 yards of displacement. 8 yards from where you started both times. Where the first time you maybe gained 8 yards, and the second time you lost 8 yards, but because there's no such thing as like negative distance, you still were displaced 8 yards, then that's what counts. And so when you have the absolute value of 8, and they put it as an absolute value, both 8 and negative 8, even though you lose the yardage, still means that it is a displacement of 8 yards. So that's what I mean. That is an example wherein a function is used to describe how these numbers are more for like displacement or distance from something, even if it's positive and if it's negative. So plugging back in the numbers, I think, kind of helps illustrate that. Now, for this example, if you have something... Oh, try not to get my head in the way. If you have something like the absolute value of 4, right? Then that means that, okay, the displacement can be either 4 or it can also be negative 4. Because, you know, if x is negative 4, then that displacement from 0 is still 4 away. Cool. Do I want to try to solve these? Yeah, sure, why not? I got time. I got plenty of time. No one's asking for homework help. Let's keep her going. Alright. Let's see, it's was it 2x minus 1? Okay. Equals 3. Alright. If I could just do it like this. So I think for these next two that I'm going to do, I'm just going to try to solve for x, just to kind of show how to do it. If you want to see if x is right, you could just plug back in the numbers, but I hope you can trust me, because really I wanted to show what the first example, what it's like when you plug back in the numbers and put it into a practical example of maybe yardage. But here is just kind of go over the process itself, just so you can kind of get familiar with it. And so if you ever have to do this and you think, okay, well, it's a little boring, but it's not too hard. Basically, you set the other value to positive or negative. So we got two equations to solve. Equals 3 and 2x, gotta watch out from my head, minus 1 equals negative 3. Okay. So then this one, let's go plus 1, plus 1. And the nice thing about this process is, again, if you're ever getting into this kind of a part of, what is this, algebra? I think this was described as college algebra. Yeah, that's what it is. Sorry for the flickering. Then, yeah, here's how you do it. It's a copy-paste the process. You do one thing to the other side. So then you have 2x equals 3 plus 1, 4. 2x equals negative 3 plus 1. It's negative 2. Divide the whole thing by 2. These are informal shortcuts, by the way. You wouldn't actually notate it like this. You'd probably do something like this. But yeah, I should do it the right way, just so no one's confused. Just so I don't get confused. And I gotta work on moving my mouth. 'Cause a bit of a random note, I can kind of do this math while talking about nonsense. So with the VTuber model, I had to really stretch my face out. And it's sometimes hard to remember that when I'm talking about something like math. Wait, can I do a screenshot of this? Oh, hold on. I'm gonna try to take a screenshot of a screenshot. Just to test. Screenshotception. There's gonna be a lot of flickering. I apologize for that. But it worked. It absolutely worked. That's cool. Alright. Now for this one, we kind of want to... What do I want to do? Huh. I think I want to solve the outside first. So basically, when it comes to absolute values, you can kind of think of them as like parentheses. So you want to kind of have them isolated. But you wouldn't just like solve it on the inside first right away. I'm gonna try this. This could be wrong, but I'm gonna try it anyways. Let's see how it works. So now we have 5x plus 2 equals, what's 9 plus 4? What is that, like 13? Yeah. 5x plus 2 equals negative 13? Hopefully. Okay. I think that's wrong, though. I'm pretty sure this is wrong. Let's keep going. Let's see where we end up. Because sometimes the nice thing about math is even if you're not right, you can at least be partially right, as long as you keep using numbers. In fact, there's been a couple times where I've had a student who does the wrong math stuff, right? The wrong process, but they end up kind of discovering accidentally some other new process that they'll be doing for school. So just because it's wrong now, and it might be blatantly so, doesn't mean that it might be... Is that right? Ugh. These are some ugly numbers we're gonna get. Doesn't mean like it's gonna be like that forever. Also, here's a cool thing. If you ever do your homework and you're wondering, man, did I get this wrong? I'll show you how to figure it out. This is actually, this is our happy little accident here. So for the first one, we're going to get 11 over 5, which is a real ugly number. And on the bottom one, we're going to get a really weird number. Let's see, divide by 5 both sides, which is negative 3. So, if you're not sure if this is correct, right? You do the process, but you think, did I do it right? I don't know. Let's find out. And the way we do that is we actually just get this formula. Can I copy this again? Paste it again? Yes, I can. That is cool. You just plug in the numbers. You plug in the numbers once you got what you got, and then we'll see. So, let's do it for both. Whoops. Because just because you might be wrong for now doesn't mean that you're gonna be wrong forever. Alright, so then if we plug in absolute value, x equals 11 over 5, then we're gonna get 5 times 11 over 5. Sorry for the tiny print. If you're watching this on mobile, so I'll try to zoom in a bit. Okay, here we go. Minus 4 equals 9. Alright, so then we have the 5s that cancel out, so then you got absolute value of 11 plus 2 minus 4 equals 9. Then you have 13 absolute value minus 4 equals 9. Absolute value of 13 is 13, so you just have Oopsie daisy. You just have 13 minus 4 equals 9. And does 13 minus 4 equals 9? Yes. 9 does equal 9. So the first one's right? This weird x equals 11 over 5, that is correct. Now this one where I wasn't sure because I had to finagle with the 4 and move it to the other side and make it, negative 13. Let's find out. And the way we find out again is just by plugging it in. So if ever you're in doubt, right? Now again, maybe if you're doing like 100 math problems for homework, yeah, it's a bit too much to double check all of them, right? That's fair. But if you have like 5 or 20, and there's like a few you're unsure of, it's worth a shot, right? Because once you get into the process of double checking your work, say for example if you're getting into tests and quizzes, then you could just actually knock those out real quick. You can like double check super fast. Just like how doing your homework makes you faster at taking a test or a quiz, double checking your work in your homework makes you faster at double checking your test or quiz answers. It's pretty nice. It's a pretty nice skill. Alright. So absolute value of 5 times negative 3 plus 2 minus 4 equals 9. Then we get negative 15 plus 2 minus 4 equals 9. Yeah, I think it is going to check out because here we get an absolute value of negative 13 minus 4 equals 9. And the absolute value of 13 is just the distance of 13, so it flips into a positive. 13 minus 4 equals 9. 9 does equal 9. Look at that. X also equals negative 3. And again, this is where math is a little weird in that as you get more advanced in math, then it becomes more theoretical and less practical. Like how can a number both equal a positive and a negative at the same time? But it does. But again, just like with the other example, you're just doing the same play and you're just using different numbers, but the same yardage is the amount. So that's kind of how it works. Alright. Now next, because algebra ultimately ends up in graphs, like oops, all graphs, I'll check that out. I think there should be some. If you just give me a moment. Okay. Okay. Yeah, this is kind of what I was talking about with the weird V shape. Oh, wait, this is for something else. Okay, hold on. I gotta kind of zoom out so I can get this whole page. Ugh. Again, pardon for any delays. Here we go. Copy. And also apologies for any flickering. There's gonna be quite a bit. Alt-tab flickers. This program. Not sure why, but it does. Alright. So this is in 2 pages. Oh. So, just to kind of walk through it, because again, they can have the answers, so it's a little hard to not spoil. For the function, this thing, fx, 4x plus 1 minus 7, okay, find the values of x such that the function equals 0. And so we're trying to find all the values that x would equal 0. Wouldn't it just be... No, no way. 4x... Some kind of... No, but that's plus 1. So it has to be like 6. It's like what? 3 2s? Yeah. 3 over 2. Okay. So the way that they want to solve it is that you would put the value set to 0, right? And first, again, it's like a weird reverse parentheses, where normally in parentheses you want to kind of solve what's inside first, right? With PEMDAS. Let's say you have like, I don't know, 5 times 2 plus 1, right? 5 times 2 plus 1. Yeah, this is the reason why they do the dots later on with multiplication instead of using the x multiplication symbol. It's because they have variables for x's, and also penmanship can be messy. So just to kind of rule that out, that's why they do the dots. Alright, so if we do something like this, right? Again, this is a bit of an aside, but I'll get to where I'm going, if you'll just stick with me. So the way that PEMDAS and like order of operations work is that you want to do the thing inside the parentheses first, right? So we basically have the same equation twice, which is 5 times 2 plus 1. But because of the placement of the parentheses, we should have different answers. I don't know if it's different. I'm going to try to figure it out. Maybe I make a fool myself and they're the same. Who knows? Let's see. 10 plus 1 equals 11. Alright. And then 5 times 3 equals 15. And the reason why that is because you solve what's the inside first. 5 times 2 is 10. You solve the inside first. 2 plus 1 is 3. And then you do the outside part, which is the multiplication. And that's why these answers are a bit different. Now, the reason why I bring that up, in that you want to do the... Why am I drawing so bad? My goodness gracious. The reason why I bring that up is that because when it comes to absolute values and functions, you kind of do the opposite, wherein it's everything outside of it, you want to simplify it as much as you can. So for here, that's why the first thing that they do is they say, okay, you have function equals this, function equals 0, right? And even if you didn't know math, if you just kind of have like, you know, similar things together, right? You have triangle equals square, and then you have an equation that says square equals happy face plus sad face. You could recognize that the square is equal to both, and you could make up your own equation wherein triangle equals happy face plus sad face, because you just kind of combine them together, right? In a similar way, with that kind of silly example, when they give you a function, you would do the same thing. And that is how they get 0 equals absolute value of 4x plus 1 minus 7, because they just simply moved the they removed the function part and they just kind of squished the 0 in there. They merged them together to make their own equation. So this part right here is the same thing as this part that they do right here, where the functions are combined. Alright, now that they're combined, then they kind of solve on the outside like reverse PEMDAS, because it's like a reverse parentheses where you solve everything on the outside of it first, and then you do the absolute value. And that's how they get the 7. Okay. Yeah, substitution, I think. The substitution property. And then they do the same thing. They could do a plus value, and what if it's negative? Solve for x, and you get 2 different answers. One is 3 over 2, and the other is negative 2. I could do the work, but then I'd just be repeating what's already written on there. If anyone wants it, that's fine. but I think I can move on because what I'm trying to get to is this weird thing. Ugh. Alright. Now, what this weird thing is the actual function itself on a graph. It is the equation that they had of, whatchamacallit, this thing. Can I take a screenshot? Yes, I can. There it is. Can I lay it on top? I can lay it on top. Oh, that's so cool. Alright. Oh, look at that. Alright. So this graph is basically this function right here drawn out. And at least for the problem that they gave us, right? Where, you know, find the values of x such that, you know, the function equals 0. We're able to find where this thing crosses on the axis where the y value is 0. How do I put it? It's a little weird. Once you get into more complex math, you have like x values, y values, z values, and stuff like that. But for when they say like fx in this level of math, it basically means y. For here, the function of x equals y. So that's why they have this 0 here, because this is where on the graph for this function, the y value, the up and down, that would equal 0, where it is not negative 10, it's not positive 10. We're just kind of looking at where does it cross this line right here. That is a mess. Sorry. This center line right there. And at this point, the function kind of branches off into a V shape because it's an absolute value. And so it bounces to 2 spots. Now the reason why it does that, yeah. Wait, is it? Yeah, -7. Yeah, the reason why it does it is because if you were to not have an absolute value, right? If you were just to have this equation, then the function would just be kind of like a line like this. It'd look like that. But because it has an absolute value, that means that for any values that are way over here, that cross a certain barrier, specifically the barrier, the y value of -7, because that right here is kind of like our limit. When you look at functions like this, when I say to solve the outside, whatever is outside the absolute value is kind of like the defining limits, right? So if there's like a -7, then your graph is gonna like bottom out at -7. If there's like if it was a +7, then it kind of looked like this. If there's like if there's no 7 at all, then it kind of looked like this. Yeah. In fact, let me do that. Here is with. Oh no, yeah, it's, you can already see it. Okay, this would be fx equals absolute value of 4x plus 1. And then this up here would be fx equals absolute value of 4x plus 1 plus 7. Yeah. So whenever you see something like a function like this, where it has things outside the absolute value, that just determines where on the y graph you're probably gonna find the pointy, the pointy piece. Yeah. And actually, it wouldn't be right on the middle. They have it slightly kiltered off to the side. That's fine. Close enough. Okay. Now, again, why is this important? Well, the absolute value part is important for understanding displacement and distance from things from one another. Whether or not it is positive or negative, the change is that. Why it's important in graphs? Why are we doing this? Why are we learning this? That's a good question. I'll try to think of something. Let's see. Why are absolute values good for graphing? And why is it important to graph these things? It makes a cool shape. I think that's good enough of a reason, right? If you want to make a function that that kind of makes a V shape like this, absolute values, those are the ones to go. In fact, if you're doing one of those things that oh, I forgot what they're called. That's where we do art but with math. And they're like on a graph. You got like points like this, 3, 4, 1, 2, 3, 4. And you kind of make like this kind of shape, right? And then if you line things up and you use a ruler, you can make like these weird, funky like shapes and colors and things. Let's see if I could do like a box. 1, 2, 3, 4. 1, 2, 3, 4. That is poorly spaced. Oh boy. Alright. Don't mind me while I doodle. I'm just trying to find a justification for why we have these functions. And then you get this close one, that 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 one. Alright, and if you have like a ruler, right, you can make these really detailed, very like kind of intricate nest looking art pieces. And you can just do it with pencil and paper and like a ruler. It's really neat, right? But if you want to get like the pointy bits and you want to do this on, I don't know, like a computer or something, I don't know what program would let you do it. But if you want this pointy shape, absolute value, that's your guy. There we go. That's the reason why. We don't need math for money or finance or finding the volume of materials and how they deform. Nah. Let's use it for doodles. Alright. Now let me see if there's more absolute value stuff I can kind of go over. I mean, that is kind of true though, right? For a lot of the more complex math, you're not really using a lot of these simple equations unless it's like a piece of a greater puzzle. If that makes sense. It's not kind of the main focus, it's just more like a part of the thing. In fact, sometimes a lot of more complex, a lot of complex thinking puzzles that I've seen that involve like this really, really complex math, right? They actually draw from like low-level algebra equations to kind of make it seem like, well, if you just take it at face value, you know, it's kind of hard to figure out or you got to brute force it. But if you remember these like old things like, oh yeah, absolute values and you know, quadratic formula and whatnot, then they become like super simple to solve. Yeah. But again, that's more like if you want to make like a puzzler. I think that's what they're called. Oh. Oh, they give you some. Okay. Let me try one. Graph the given function by hand. Let me botch this one. Oh shoot, I'm almost out of time. Okay, yeah, let me just try one. Sorry, I'm having a lot of fun with the copy pasting. Again, I apologize for the flickering. Alright, now there's a couple ways to do this, right? I could probably just eyeball it and do it, but I'm going to try to do it the brute force method, which is like the most tedious kind of one by one, piece by it. And I think it should be fine. If I go by 1, 2, 3, 0, -1, -2, -3. And the way I'm going to do it is I'm going to just try to plug it in. So if I plug in, let's say 1, right, into this thing, and I do -2, well, the absolute value of 1 is 1. So that just becomes 1 minus 2, which equals -1 equals y. So then I would get the, whoopsie daisy. For the value of x equals 1, somewhere on this line, I would need to get, let's do -1, -2, -3. 1. Now I'm gonna guess that there's gonna be a y shape. And I'm gonna guess it's gonna be here at the, or sorry, not y, a V shape. I'm gonna guess it's gonna be somewhere around the -2, but we'll see. Let me get there first. All right. So for the value of 1, I have -1 for y, so that point kind of goes here. Okay. If my x value is 2, absolute value minus 2, so I have 2 minus 2, and then that would equal 0 equals y. That point goes right here, because I plug in the value for x, and the answer is y. I plug in the value for 1x, and the answer is y here. Alright, so I'm going to plug in 3 now. 3 minus 2 equals 3 minus 2 equals 1 equals y. Right there. Okay. And let's work a little bit backwards. 0 minus 2. Absolute value 0 is actually 0. It's nothing weird. It's not like dividing by 0. It's nothing crazy. It's just 0 still equals 0. You can't really have a -0. Even if you do -0, it's still 0. Surprise. -2 equals y. So that would be right about here. Alright, now here's where we get the little twist in the math. I'm gonna zoom in for this one. Alright, what if we do -1? I don't know if I want to kind of door the explorer it and just say, like, you know, can you find the absolute value? And guess what it is? Yeah! It's 1. Alright, -1 equals y. So to that end, -1 equals y, -1 right here. Alright, and just using kind of pattern recognition, I'm just going to predict it might be something like this. And then once we start connecting... Now the nice thing about functions, right? If you kind of brute force it this way and you kind of do the points and stuff, you ever do those connect the dot puzzles? Where they just have like all these dots and you gotta make a shape? And you're like, oh cool, it's a question mark. Or some kind of animal. It's basically like that, where you connect all the dots, and that's your function. It should be very straight. The only reason why it's not is because I'm bad at drawing. But if I were to answer this, I would draw the thing very neatly, maybe use some graph paper, and then you know, make sure to make clear, if I haven't had it already, this is the function of y equals x minus 2. There it is. Alright, here we go. So that's a bit about absolute values. What it's good for is, I guess, maybe functions and drawing. But the main thing is to kind of understand the displacement and the distance, where if you have like the same, whether you gain or lose 8 yards, it's still 8 yards that is being moved from where you started. stuff like that. Is there anything else I could cover for absolute value for today? Probably, but I'm out of time. Okay. But hey, to anyone that came by, thank you for listening. I hope this kind of helps. Now, maybe next week there'll be someone by that I'll tutor, so it'll be a bit more structured and handling that. And if anyone's interested in tutoring one-on-one, let me know. I can try to schedule something on the weekends. Yeah. But until then, to anyone that came by to listen to me ramble about this thing, thank you for coming again, and I'll see you next week. Have a good one.